A very good evening. This is Morgan from Shanmugha College of Engineering and Technology. I belongs to Agriculture Engineering Department. I'm going to present a topic on Introduction to Fluid Mechanics. So let me go with this earlier before going into fluid mechanics. The mechanics is the oldest physical science that deals with both stationary and moving bodies under the influence of forces. The mechanics which deals with the body at rest is called statics, while the branch that deals with body in motion called dynamics. The subcategory fluid mechanics is defined as the science that deals with the behavior of fluid at rest, that is fluid statics, or in motion, fluid dynamics, and the interaction of fluid with the solid or other fluid at the boundaries. The study of fluid at rest is called fluid statics. The study of fluid in motion, where the pressure forces are not considered, that fluid is called as fluid kinematic. Here the pressure force is predominant and it is considered in motion, the branch of science called fluid dynamics. It has been divided into several categories, especially the study of motion of fluid that are particularly incompressible. Incompressible means here the density of the fluid does not change with respect to the time to time or place to place, especially the liquids, water and gases at low speed is usually referred as hydrodynamic. A subcategory of hydrodynamic is hydraulics that deals with a liquid which is flowing in pipelines or open channel, example river, streams or channels. And gas dynamic, it is completely focusing on the gas which is flowing through pipelines or nozzle at high speed. Here in case it is a compressible liquid, fluid, so here the density will vary from place to place and point to point. The category aerodynamics deals with flow of gas, especially air, over bodies such as aircraft, rockets, automobile at high or low speed. Some other specialized categories such as meteorology, oceanography, hydrology deals with naturally occurring flows. Here let me go. What is fluid? A constant shear force which is applied, a constant shear force which is applied in the portion. Here this is a plate and here it is a plate. A constant shear force which is applied in the solid boundary eventually, see here this is a force, eventually stops deforming at some fixed strain angle, whereas fluid never stops deforming and approaches a certain rate of strain. Here this is the contact area. In these two surfaces, in between the two surfaces, the liquid which is flowing inside the between the two surfaces. Here the surface area A, shear stress where tau is equal to force by area. So because of this movement of fluid between the two plates, the plate eventually stop deforming at some angle that's called shear strain. We can indicate it by the term called alpha. So here the deformations of rubber eraser placed between two parallel plates under the influence of your, so one plate is pulling like this, one plate is moving this side. In between the movement of these two plates, the rubber is deformed. So the deformed portion is at the surface. At the surface, because of this deformation, if the force is acting, the shear stress will be developed. Next, in a liquid, molecules can move relative to each other, but the volume remains relatively constant because of strong cohesive force between the molecule. As a result, a liquid shapes a container and it forms free surface at the top. As a gas, it expands until it counters the wall of container and fills the entire available space. This is because the gas molecules are widely spaced and the cohesive force between each molecules are very small rather than the liquid. Unlike liquids, gases cannot form a free surface because everywhere the gas can get filled, but once if the liquid is filled in the container, above the liquid it have a free surface. There is some difference between liquids and gas. Difficult to compress and often regarded as incompressible. And I have said the incompressible, here the density is constant. Gas easily to compress change of volume is large, cannot normally be neglected and related to temperature. If the temperature of the gas it gets varied, the viscosity gets varied. Occupies a fixed volume and will take the shape of the container. No fixed volume, it changes volume to expand to fill the containing vessels. A free surface is formed if the volume of the container is greater than the liquid. Completely fill the vessel so that no free surface is formed. Some of the applications area of the fluid mechanics. Mechanics of fluids extremely important in many areas of engineering and science. For examples, biomechanics, blood flow through arteries and veins, airflow in lungs, flow of cerebral fluid. So next we'll go for house code. Already we know the piping system for cold water, natural gas, sewage, piping and ducting network of heating and air conditioning system, refrigerator, vacuum cleaner, dishwasher, washing machine. These are some of the common examples which the fluid mechanics concepts are involving in households. Next, metrology and ocean engineering, movement of air current and water current. In mechanical engineering, design of pump, turbine, air conditioning equipments, pollution controlling equipments, etc. And also we go with the design and analysis of aircraft, boats, submarines, etc. In case of civil engineering, transport of river sediment from one place to another place because of the movement of water or even air. Pollution of air and water, design of piping system, flood control system. In case of chemical engineering, the chemical processing equipment, mechanical, already we have discussed. This is the applications area of fluid mechanics. So the number of fluid engineering applications is enormous. Breathing, blood flow, swimming, pump, fan, turbines example. Here I'm just given some examples of missile aerodynamic and automobile aerodynamic. When the missile moving towards the target, depending upon the flow actions, the mission is moving on to depend opposite side there is a flow. Same wise in case of aerodynamics, it's against the airflow. The same applications areas, high speed train, wind turbine, smoke from a stack, pollutant dispersions over a city. Like we'll have a propeller, fan, that is a fan inside that is called as impeller, in a pump as well as a turbine, a jet engine propulsion, cross flow fan. So these are another some applications areas in especially on sports, sky jumping, golf, swimming. Swimming it gives the best examples of the movement of water forward and backward. Football, cycling. These are the some common and typical examples of examples as applications of fluid mechanics. Thank you. We will discuss the remaining topics of fluid mechanics in some other class. Thank you.